I welcome you to this video. We shall learn how to graph tangent and cotangent function. So this graph is tangent versus cotangent. What is the difference between them and how can we differentiate in their graphs? So both things are on the board. Here you see the function is y is equal to tangent x. We need period. You should remember the period for this function is pi. Just like for sine and cosine period is 2 pi. Amplitude, there is no amplitude. So amplitude is undefined. Undefined. A. Previously A was amplitude, but here A is not amplitude. A is a coefficient written before this one, and this is 1. And always take be positive. If negative number is there, we make it absolute. Graph interval. For the function tangent, graph interval is taken half of this one. I mean, we divide it by 2, pi over 2 minus pi over 2. Basically, tangent graph exists on both sides of the y-axis line. This is pi over 2 and minus pi over 2 is here. Okay? And at these points, tangent is undefined, so asymptotes exist. There is asymptote. There is another asymptote. I give you a quick view of this graph. So quickly, how can you graph this one? Without taking any points, any calculations. This is the middle point. Graph will pass from this one. And I take the midpoints. Look at the picture, how I'm graphing. This is the graph for tangent x function. Any graph for any period, you will graph like this one. Don't write any number here. Just the idea I want to give you here, graph is existing both sides of y-axis in this way. Now we shall label according to the given question. Here pi, and we shall decide an interval. This interval gives us a good view of the graph of the tangent function. And this is the starting and other is the ending point. So these both points are over here. This is negative pi over 2 and this is pi over 2. This is the midpoint 0 and take the midpoint over here, which is pi over 4, and on negative side this is negative pi over 4. Now look at here. What about this one? Go over here, this point, and corresponds to take the value of y, this is 1. You can check tangent pi over 4 is how much? 1. So tangent pi over 4 is 1, so this gives the value of y. This is basically point of inflection. At this point, the graph changes its concavity, but we are not discussing this thing in a detail. Only this point you can consider over here. And same thing is over here. If you take this point, against this you take the value over here, negative 1. So this is a graph for y is equal to tangent x. Okay? Now, the graph of cotangent x. For the graph of cotangent x, one thing, period is same, period is pi. And what about the amplitude? No amplitude. Amplitude for cotangent is undefined. And A is a coefficient before this number, which is 1. Always take its absolute. If it is negative, make it positive like this. Graph interval. This is a cosine function, a cotangent function. Its graph interval is from 0 to pi. 0 to pi means the graph exists between 0 and pi. So this is on right side of this y-axis line, this is pi. And we know cotangent pi is cosine pi over sine pi, and this is undefined. So asymptotes exist at this point. There is asymptote at this point. Now we have to graph it. The graph for cosine function, cotangent function is 0 to pi. Okay, look at here please at the board. Don't do anything. Just make the curve. Remember the shape of the curve. Okay. Bring close to the asymptote and leave it. This is the shape for the cotangent function always. And you can distinguish between this cotangent and tangent function graph, which is over here. You can see the tangent function graph is on both sides of y-axis, whereas cotangent is on right side of y-axis. Now you have to label the graph. Labeling comes according to the function, and this is the midpoint, which is pi over 2. Take the midpoint here. Okay, what is the half of this one? Pi over 4. Pi over 4, pi over 4, again pi over 4, so 3 pi over 4. Okay, so this is our graph for y is equal to cotangent x. Any question? Okay. Now, if you know this thing, the graph for the tangent function, we can draw a graph with any period. For example, I have this question for you now. 1 over 3 tangent x. What happens with this one? 1 over 3 tangent x. We have to write the period for this one. Period is pi divided by 1. Why 1? Because the coefficient before x is here 1. This is 1, and always we divide by this one to find the period of the given function. Amplitude is undefined. For all tangent functions, amplitude is undefined. What about a? A is a coefficient written before this one. What's this coefficient? 1 over 3. Because period is same over here, pi. So we take the graph interval by taking pi over 2 and negative pi over 2. This gives us a better view of the graph. So that's why we are taking this interval for its graph. So what will happen? Everything is same. We draw the graph. Okay. And this will be 1 over 3, negative 1 over 3. Understand this one? So just simple thing is here. You remember the shape of this graph, which is cotangent. Cotangent is always like this. Okay. And now the next thing is to label it. Label according to the period, according to the value of a general. For example, I have 3 instead of 1. What will happen? The value of a will change. A is 3. Graph interval will remain the same because period is pi. Whatever period is over here, the period becomes the end point. So 0 to pi is the graph, and the shape of the graph is like this. And here, this point you have to show over here, this will be 3. Okay. Similarly, under this, mark the point over here, its intersection. So this will give you the value on this side, -3. Okay. In case of 1, I think I did not write 1 over there, so you can write 1 if it is. If it is 5, write on 5. So this is point of intersection of this x value and this number. Okay. Now, I give you another question. For example, the question is, instead of y, I'm writing fx equals -1 over 3 tangent of x. I'm not changing much, only changing the sign of this one. Okay, 1 over 3. What will happen? Period of tangent x stay the same because there is one coefficient, and divide by 1 give you period pi. A is a number before this one. This is the value of A, which we write over here, but this is negative, we take positive. Always take absolute, this one. I'm taking absolute, this one. If you take negative, it is coming negative below this. Okay. Now what should I do? How to construct the graph for this one? Always go like this, asymptotes, because this is a tangent function. Graph comes between these two asymptotes, and then mark it. Okay. So here, the graph interval is important to define, and this is half of the period, pi over 2, negative pi over 2. So without marking, so you can graph this curve. Remember this shape for the graph whenever there is a tangent function. And now on this side you have 1 over 3, -1 over 3 value against this point. But if you look at the question is something different. It is not the graph of tangent 1 over 3 tangent x. No, it is a graph of -1 over 3 tangent x. Negative means reflection about x-axis. So this negative sign will give you reflection. Okay, this is a reflection of this graph. How to make this reflection? About? Okay, so show its reflection of this graph. Yeah, we switch it. Okay, so you can graph over there from this. Okay, so parent function graph we don't want. Show it dashed like this. It means this is our working. So the graph we need, that is -1 over 3 tangent of x. So this is y equals -1 over 3 tangent of x. Okay. Next, we go for the cotangent. In cotangent, we make, I just make a change over here. If I write here -3, okay, y is -3. So first of all, we have to draw the graph for cotangent x. How to graph? Period is pi, a is 3, interval, and so on. Okay. The shape of the graph we know. This is the shape of the graph. We can mark the points because period is the same between 0 to pi. But there is minus sign, negative. What negative means? Reflection. Okay. So we shall take its reflection, okay, about this line. So graph will take the shape. Okay. So if you want to show the point, this one you can check its value is going to be the same and on this side. So this is your required graph. Y equals -3 cotangent of x. So the only thing is we have to remember the shape for the tangent function graph and the cotangent function graph. Whenever cotangent function comes, in case of cotangent, we have to graph between 0 to this one. Okay. And then you can make transformations on this one as given in the question. Because this is for one period, you can extend it for many periods. This is one period, pi. 1, 2, 3, 4. So you can extend over here and you can draw another graph of this one. Because there are unlimited number of graphs which we can draw on both sides. Any question? Okay. Now I have a question for you. Y equals 2 tangent of x. Okay. Graph this function. The value of a we shall define and write the period. A all of you please work on this question yourself independently. Okay. This is the tangent function and we know the shape of tangent. Tangent is on both sides of x-axis, of the y-axis. Period is 2 pi, sorry. Period is pi over 1 because coefficient is 1. So this is going to be 1, pi. This 1 we take over here always. And this 2 I write. And half of this one is pi over 2 minus pi over 2. This is the graph interval. I mean one complete period is pi. When you add this and this one, this gives you pi, total distance. So between these 2 points, graph will exist. But you don't need to write anything. Just sketch the graph without labeling, without looking any value in the graph. This is given. Draw the graph. You know, graph will go like this. This is the shape of the tangent function graph. We don't know. Any question comes, this is the first step. And then you have to write it for the particular given graph and impose the conditions on this one. What are the conditions? Negative pi over 2, write down over here, and pi over 2. We write its midpoint, pi over 4 minus pi over 4, and this value, take this point directly above this one on the graph and here, and this value is this a. This is the a basically. And same thing is over here, directly under this one, you have a point, this is negative 2. This is asymptote. And if you want to write the equation, asymptote is pi over 2. And this asymptote is x equals negative pi over 2. This is a graph for y equals 2 tangent x. Okay? Now, we have another graph with y equals negative tangent x. What will happen? Any question about this? Now, I change this one with negative. Okay? So what changes will happen over here? Amplitude remain undefined. A will be negative 1 absolute, you can say 1. Because period is pi, so our interval is going to be negative pi to pi over 2. For graphing it, we graph in the same way. Only change will happen where? At this point. This is 1, negative 1, and this is the graph y is equal to tangent x. It's all working. Now, but we see there is a minus sign, negative sign. It means, yes. So this graph should come over here, this way. Understand? And just mention it. This is y is equal to negative tangent of x. You can write as many cycles as you want. This is known as one cycle of the graph. One cycle means for one period. This length from this negative pi over 2 to pi over 2, this is one complete cycle. And so many cycles you can make. There are 4 units, 1, 2, 3, 4 intervals. You can extend this graph over here if you like. For more, here, this one, and this is the midpoint. You can extend this graph like this because we are taking negative. I'm not writing any values there, but I'm extending it. But you know, period is pi, so you can make it. Add over here, and you can, pi plus pi over 2 is what? Pi plus pi over 2, 2 and 3 pi over 2. So you can write over here 3 pi over 2, and you can find their middle point, whatever the method is, and we can construct a series of graphs along this one. Because there are infinite number of loops, cycles of this graph. Okay. Now we have these 2 questions. First one is y equals tangent of 2x. So first of all, we write the value of a. You know, the number before this is a. Amplitude is undefined. Period. Period is 2 pi in this case because it is tangent function. Pi over, divide by this coefficient, which is 2. So period is pi over 2. Graph interval. Graph interval, I told you, we always take half of the period. So this is pi over 4 minus pi over 4. Okay? Our graph will be between this interval. So without looking at this one, just on both sides, draw the asymptotes. I draw asymptote on this side. And approximately same distance I'm taking on the other side. When you see, this is a graph for tangent function. Just write down this one and draw it. Okay? Axis and graph it. If I graph for tangent function, so it is like this. Okay? Now we have to label it. How to label? Interval is with us. Negative pi over 4, 2 pi over 4. Mark the other point. This is 0, its midpoint and its midpoint. This is pi over 8, negative pi over 8. Okay? Directly over this, find this point of inflection. And here the value is this one. Whatever number is there, this is 1. And same under this you take, on this side you pay by negative 1. This is the graph for the function y equals tangent 2x with 100% perfection. So what is important here? Just to remember the shape for the graph. Graph exists on both sides of y-axis. X-axis, y-axis. Okay? Let's have new question. Y equals tangent of 2 x minus pi over 4. In this question, write down the period of this one first. The period is tangent. Usual period for tangent is pi. So this pi over 2. This coefficient we take there. So pi over 2 is the period. Then we go for a. There is 1. So a is 1. Graph interval. Yes. How to find the graph interval? Yes. Half of this one, pi over 4, divide by 2, just this one, and negative pi over, oh, sorry, this one is, tangent, which is tangent, not cotangent, pi over 4. Okay? So this is the interval for this one. So if this one is the interval, so graph exists on both sides, you know, if it is a tangent function. But see here one thing. Phase shift is there. X minus pi over 4. So starting position and ending position will be different. So if we go for the phase shift, you put this thing, x minus pi over 4 is equal to 0, and this give you x is equal to pi over 4. Okay? X is equal to pi over 4. Phase shift will affect its starting position and ending position. This phase shift you have x is equal to pi over 4. We shall add over here, remember, add over here this one, pi over 4 plus pi over 4. Once you are adding, this give you 0 and 2 pi over 4, pi plus pi over 4 plus pi over 4. This give you 2 pi over 4. You calculate pi over 2. Okay? So your graph is between 0 and pi over 2. Understand? So graph is between 0 and pi over 2. So 0 is over here and pi over 2 is over there somewhere. asymptote. So your graph exists between them. What's the shape of the tangent graph? Do we know? Yes. We know its shape. So just graph it, please. Okay. Bring close to the asymptote and leave it. Now, what's the next step? Label it. So label it. This is the midpoint, pi over 4. This is pi over 8. And when you add pi over 4 plus pi over 2, what's the answer? 3 pi over 8. Okay? So our start is where? Our start is here basically. Once we do this is our start. This is our start. Three pi over 4 and divide by 2. Yeah, 3 pi over 8. Okay, students? Any question? Thank you.